Hello guys, welcome back. Today we are going to discuss about production of X-rays. Now just a small introduction about X-rays. Now the person who made X-ray possible was Wilhelm Röntgen. He did that in 1895. So when did he do it? While studying cathode rays in a gas discharge tube. So what separated him from others is that he discovered another type of radiation that could be detected outside the tube. Okay. Now let's talk about the X-ray tube, a modern Coolidge X-ray tube. So it consists of a glass envelope with vacuum. There is no air inside, so not to disturb the electron emission. Now here are two ends, and cathode, anode. Okay, cathode, anode. The cathode is made up of tungsten filament. Now when this tungsten filament is heated up, the electrons are released in this process called thermionic emission. Okay, and these electrons move forward in the direction of anode. The material of the anode is copper. Now there are two important requirements of anode. One is that to remove the heat due to this electrical field. Okay. The another requirement is the optimum size of the target area. And what is the target area? The target is tungsten. Tungsten is chosen as the target for its two properties. One is the atomic number, which is 74, which is higher, and the melting point, which is 3370 degrees Celsius. Now coming to the X-ray circuit. Now the X-ray circuit's main objective is to produce the heat through current. Okay. Now let's divide it into two main components. One is a circuit for heating the filament, a circuit for applying a large potential difference between the cathode and anode to accelerate electrons. So this is our hero, the X-ray tube. Okay. Now this filament is the cathode. Okay. Now this cathode requires 10 volt 6 ampere current. Now this is achieved by a step down filament transformer from the main power line. Okay. Now coming to the anode. Now this anode is connected to a step up high voltage transformer with a rheostat. A rheostat is nothing but a variable resistor. You can control the amount of current going through the circuit by a rheostat which uses variable resistance. Okay, and this can be read through a voltmeter. Now this anode's job is to pull the electrons from the filament by giving a charge, and thereby X-rays are produced. Now coming to voltage rectifiers. Now there is something called as inverse voltage cycle. What is inverse voltage cycle? It is where the anode becomes relatively negative compared to the cathode. So what happens is that the electron flows in the opposite direction. So as a result, the electrons start bombarding the tungsten filament, which might damage the filament. So in order to correct this, there is something called voltage rectifiers. These are used to prevent the tube from conducting during the inverse voltage cycle. The mechanism is similar to the X-ray tube except that it's opposite. Okay. Now there are two types of rectifiers, voltage rectifiers. One is that valve rectifier and one is solid state rectifier. Now regarding solid state rectifier, what we will do is that these conductors, we will coat these conductors with semiconducting elements such as selenium, silicon and germanium, and its job is to prevent inverse voltage cycle. Okay, and also another useful thing is that this voltage across the tube can be kept constant. Now coming to high output X-ray generators. There are three high output X-ray generators, that is three-phase generator, constant potential X-ray generator and high frequency generator. Now let's discuss them one by one. Three-phase generator. Now this three-phase generator is high output X-ray in short period of time. So this is naturally used in patient imaging. So to minimize the patient motion. Okay. Now high voltage is applied to the X-ray tube in three phases and a 6 voltage ampere is applied. A 6 voltage is applied. So here what happens is that it is connected to a step up transformer. One step up transformer. The voltage across the tube is always kept at maximum. Now coming to the second part, that is constant potential X-ray generator. Now this three-phase line voltage is coupled directly to a high voltage transformer. Okay, now it is regulated by rectifiers, capacitors and triode valves. Rectifiers, capacitors and triode valves. So what happens is that the ripple is less than 2%. Okay, now coming to third one, that is high frequency generator. Now high frequency generator is smaller compared to the rest of the two which we discussed earlier. Now here a single phase line voltage is used and then it's fed to a chopper and inverter circuit, and as a result the DC voltage, the direct current voltage, is converted to high frequency AC voltage. So the principal advantages here compared to the rest of the two is that it is a small size, that is reduced weight and size, so it becomes more practicable, and there is a greatest achievement of efficiency of X-ray production, and there is maximum X-ray output as per MAS and shorter exposure time. So coming to physics of X-ray production. Now there are different mechanisms of X-ray production. Okay, the two are Brimstone and characteristic. Now let's discuss them one by one. Coming to Brimstone, the definition of Brimstone is there is a sort of collision between high speed electron and the nucleus. Two players are involved here, that is the electron and the nucleus. Now what happens is that the electron, as it passes near the nucleus, there's a deflection of the path due to the charge. Okay, now what happens is that as a result the energy is radiated. This X-ray which is radiated is called as Brimstone. Now coming to characteristic X-ray. What happens here is that now the high speed electron interacts with the atoms. Okay, so here is the primary electron. Now in an atom we know that there is K shell, L shell and M shell. They all contains electron. M is the outermost, K is the innermost. Now let's say in a hypothetical scenario, primary electron hits the K shell electron. Now all the energy of the primary electron is transferred to this incident like the target electron. Now the K electron is ejected. It is given by this equation. Now it is ejected. Now there is a void here. So what happens here is the electrons from the L shell and the M shell jump here to cover this void. As a result, what happens, due to like the energy used, there's an energy radiation here. Now this is called as characteristic radiation. Now coming to X-ray energy spectrum. Now practically speaking, X-rays have a lot of energy which is heterogeneous in nature. Some have low energy, some have high energy. Now if we take the spectrum graph, the Brimstone X-rays are superimposed on the characteristic radiation. So what happens is that there is a natural filter, that is an inherent filter, when an X-ray is produced freshly from the tube. Okay. Now what happens in real life application, filters are added near the beam so that it improves the power of the beam and thereby it increases the penetration power of the X-ray, which is the basis of radiotherapy. Now coming to further info on this topic, that is the average energy of the X-ray is equal to 1/3 of the energy of the maximum energy of photon. So you want to know the average energy of the X-ray spectrum. So what we have to do is that we need to know the maximum energy of the photon in that spectrum and divide it by 3. That's it. Then you'll get the average energy of the X-ray. Now another term which is used to describe the quality of the X-ray beam is HVL. I'll take a separate video. I'll make a separate video on HVL, that is half value layer. Now coming to the operating characteristics. Let me introduce to one unit called exposure. What is exposure? Exposure is the ionization of air which is in per unit mass. Let me repeat it again. The ionization of molecules produced in per unit mass of air. Okay. Now let's take a look at this graph. Now the relation between the tube current, the X-ray tube's current and the relative exposure rate, it is in a linear fashion. Okay, linear fashion means If you increase this current by, let's say, 2 times, the relative exposure rate also increases by 2 times. But it's not the same for tube voltage or filament current. Okay, it increases exponentially. Initially it's in the linear part, but actually it increases exponentially. Okay, now a small change in filament current produces a large change in relative exposure rate. So that much important is filament current. Now that's all in this short lecture. Thank you for your attention. If you like this video, please press the like button and subscribe and comment your thoughts. Thank you.